Our presentation contents are introduction, objective, application, apparatus, block diagram, circuit diagram, how it works, simulations, implementations, experimental data, efficiency, and discussion. The introduction of our group members are Bhawal Apurba, Hassan Sakib, Abha SMA Maula Choudhury, Shubho MD Wahiduzzaman, Sajin MD Imtiaz Alam. The objective of our project is to develop a passcode security system using digital logic circuits. This system can set password, use the password to do specific tasks, and ensure security in any object or task. Application of our project is to use it in lockers, have access control in offices, have digital device security, and are used in home security systems. The apparatus of our project is quad NOR gate, quad XOR gate, counter, NOT gate, and 555 timer. A counter is used to count how many times the password is wrong. The 555 timer is used to connect with the display, and the other gates are used for logic. The other apparatus are 4 position dip switches and push button switch. 4 position dip switches are used for input hidden code and uh, input passcode, and the push button is used to activate the system. Other apparatus we have used are breadboard, wires, and 9-volt battery. Next, our next presenter will present.
We used XOR gate as bit comparators, NAND gates to check all bits being matched, green LED for correct pass, red LED for incorrect pass, and buzzer for multiple incorrect attempts. As we can see, our system buzzer buzzes the alarm after 3 times. It's our block diagram. There will be a hidden passcode and an input passcode. The hidden passcode contains 4-bit, and input passcode also contains 4-bit passcode. Each of the bits will be matched using XOR gate. Then every bits is matched or not. It will be checked by a checker. It will be a NAND gate. And if all the bits are matched, that we can see the hidden passcode and input passcode are matched, then the output will show green LED. And if some bits are not matched, the output will show a red LED. Then it will go through a binary counter, and after multiple times, it will buzzer a ring. We can see after 3 wrong input, the system will notify everyone. Then how it works. After it started, we have to set a hidden passcode. Then we have to set a passcode for the entry. Then we have to check the similarities between them, hidden passcode and set passcode. And then if all bits are being matched, then we have to do a task. If those are matched, then we have to do some specific task. If not matched, then it will show a wrong password indicator. Then next presenter will present from next.
Thank you, Imtiaz Sajin. for your contribution. Am I audible?
Yes.
Okay, so moving forward to next slide. Here we have the circuit diagram of our project. So as we earlier discussed in the block diagram, we have here uh, tip switch for the hidden code to set the hidden code and input the response from a user. We have used here a 4-position deep switch. The way the circuit work is we have used here a 4 XNOR gate to check if the 4 input matches with the hidden code. If this 4 input matches with the hidden code, then all these gates will uh, produce 1 in their output side, and thus we have passed this 4 output through a NAND gate for quad NOR NAND gate. Uh, then we have used here key space to initiate the technique. We have used this push button. So when someone give entry in the input deep switches, then if that 4 input matches with the hidden code, then we'll get an 0 through this NAND gate. And over here, this LED 5 will glow, which indicates that the input password was correct. And for other cases, if the password doesn't match, it will produce this glow this LED 4, which indicates that the password someone entered is wrong. So over here, we used a mechanism that counts how many tries user tried with the wrong password. So we used a 7493 IC, which is a counter that counts the number, and we modded this to count from 0 to 3, so that someone cannot try more than 3 times with the wrong password. To indicate this event, we have used here an LED 3. When someone tried more than 3 times, 2 times, in this LED 1 will glow, and we have used here LED 7-segment LED display to display how many tries someone tried with the wrong password. So it will show 0, 1, 2, 3, and it will start from counting 0 again when uh, it it faced the situation someone tried more than 3 times with the wrong password. In the next slide, I will show some simulation of the circuit. So first, we have tried here with the wrong password, and this counter count this, and with this BCD decoder, we are showing this is that someone tried with the wrong password and LED 4 glowed. Here we have tried with a wrong password position again, and this counter counts this to 2, and this LED 4 glows. Now, third time when we tried with the wrong password, this uh, LED display start counting, shows from again 0, and we couldn't record this event to show glow this LED 1 because it was too fast. So if we can use a buzzer with a with transistor, then it might show it might buzz in a in long time. So here we have finally used a correct sequence, correct position that matches the hidden code. And here we have we can see that LED 5 glows. That indicates that the password is correct. And also the L7-segment display shows that it is still in 0. So yes, it confirms that the position matches, and the code are inputted code is matched with the hidden code. So I would like to request my next presenter to present.
Hello, do you guys can see my screen? Hello. Hello, you guys can see my screen? Hello.
Yes, we can hear you.
Hello and assalamu alaikum, sir. Today, my part of discussion is implementation. At first, we bought all our equipment from the market, and that is our initial stage, as we can see in the picture. Then we implement all the things according to the logic diagram. That is our final phase. Then there is experimental results and comparison. Over here in the table, we can see there are 15 number of tests, and there is a hidden passcode, entered passcode, and correct and incorrect. There is a buzzer and expected result and the result found. Over here, if there are incorrect number of incorrect terms, three times are true, then the expected result is mismatched and the buzzer will be buzzed and the result will be as expected. Here, the hidden passcode at the first number of test is 0010, and the entered passcode is also 0010, which is the correct passcode. And we can see here it is shown true, and the incorrect shows false. And the expected result is matched, and the result found as expected. But if the incorrect number of term is true three times, we can see the expected result is mismatched and the buzzer will be buzzed. Here we can see not expected result two times, and that is because of loss connection or short circuit. Efficiency. The efficiency of this uh, The efficiency of this circuit is determined by number of as expected result divided by number of total test into 100%. The number of expected result we found in the table is 13, and the number of total test we did is 15. Into 100%, we get the result is 86.6%, and that is our efficiency of this circuit. In the next slide, Jim will continue from here.
The first one is less combination of passcodes, only 16 combinations. Having only 16 possible passcodes combination makes the system vulnerable to uh, attackers. When an attacker especially tries tries to attack until the correct one is found. So uh, the second one is easy to trace any hidden pass. মানে we can try allowing only 3 times attempts at a time. We can do it. Dependency on hardware reliability. uh, Relying heavily on hardware for security, introducing risk. If the hardware is compromised, it could lead to unauthorized synthesis. Additionally, depends on specific hardware may become problematic if it becomes obstacle or experiences failures. The next one is not effect for mass production. Mm, it it is its security system is not efficient as mass production. It may be harmful for mass production. And the last one is sequencing in the pin code is not possible. Okay, now going to the next slide. Discussion and review. Integration of multiple components, challenges faced while integrating diverse components like gates, LEDs, timer, buzzer, etc. And the second one is error found on gate logic. Collaborated with team members, identified and corrected the gate connections. And the third one is error found while implementing. We found many errors while we were implementing the circuit. And the Last one is user friendly, easy to use password, so anyone can use it. If you have any question, you can ask me and our group. Thank you, everyone.